For 4.5 test review number 5 and 6, we are doing the same thing we did for 1 through 4, but then we have to actually put them on the graph. So let's go ahead and look at number 5. What we want to do is go ahead and factor this. For the numerator, you're just going to leave as x minus 2. The denominator, you could leave it if you really want to, or you could factor out the negative 1 and get x plus 2. Now we are ready to go ahead and identify the x and y intercepts and also the asymptotes. For the x-intercept, I am setting the numerator equal to 0. I get x minus 2 equals 0, and I get x equals 2. For the y-intercept, I plug in the value of 0, so I get 0 minus 2 over negative 1 times 0 plus 2. That gives me negative 2 over negative 2. Let me show you the work on that. Negative 1 times the 2, which is negative 2 over negative 2. So y equals 1. For the vertical asymptote, I set the denominator factor with the variable expression equal to 0. So that's x plus 2 equals 0, and I get x equals negative 2. If you take the original denominator and you set that equal to 0, negative x minus 2 equals 0, you would add the 2, you would get negative x equals 2. And because of that negative out front, now I have to divide by negative 1, and I still get x equals negative 2. So no matter how you do it, you're going to get x equals negative 2 for that vertical asymptote. Now the horizontal asymptote, I am going to take and look at the n value and the m. Okay, both n and m are 1, so they are equal. So n is equal to m, which means I take the leading coefficients, 1 over negative 1. So I get y equals 1 over negative 1, which is equal to 1. So y equals negative 1, negative 1. Okay, now I have my values that I need to plot onto the graph. So for my x-intercept, I have 2. For my y-intercept, I have 1. I will plot my x and y, or my vertical and horizontal asymptotes. So my vertical asymptote is at negative 2. Okay, let me try that again. That was supposed to be a line. Okay, negative 2. And my horizontal asymptote is at negative 1. Okay, and there we go. So now I need to test my behavior of the graph. So I'm going to go ahead and erase all of this. And the behavior, what I need to do is test 0.1 units away from the negative 2, or away from the vertical asymptotes. I don't have to worry about horizontal asymptotes, only the vertical asymptotes. So I'm going to test okay. I'm going to test if I go 0.1 units away from negative 2, I get negative 2.1 and negative 1.9. What I'm looking for is when I am very close to the asymptote, am I going towards positive infinity or am I going towards negative infinity? And all I need to know is when I plug these numbers in, is the outcome a positive number or a negative number? So here is negative 2.1, the testing. I just plug it in for x. So negative 2.1 minus 2 over negative value of negative 2.1 minus 2. Well, when I subtract negative 2.1 minus 2, that is a negative number. When I plug in negative 2 for the denominator, now I have positive 2.1 minus 2, which is a positive value. When I divide a positive and a negative value, my outcome is going to be negative. So at negative 2.1, which is to the left of this vertical asymptote, I am going down towards negative infinity. So I just want to draw an arrow going that way because that's part of my graph. Now, when I graph this, I'm going to need a point to go through. I have no points either above or below this horizontal asymptote. So I don't know if I'm going to come up here and then just stay underneath the asymptote, or I'm going to go up through the asymptote and then level out to follow the horizontal asymptote. Okay, but now I know I'm going towards negative infinity because I got a negative value for my answer. When I plug in negative 1.9, I get negative 1.9 minus 2 over the opposite of negative 1.9 minus 2. So here I start with negative 1.9 and I subtract 2. So that again is going to be a negative value. Here this converts to positive 1.9 minus 2, which is negative. And two negatives will make a positive. So at negative 1.9, which is to the right of this asymptote, I am going to positive infinity. So now over here on the right hand side, I am ready to graph. I'm going to go down from the arrow. I will go down towards the horizontal asymptote. I want to make sure I go through both of these points, and I'm going to level off and run along the horizontal asymptote. Be careful that you're going to just kind of draw a straight line going down a little bit on an angle. Don't bring this up. Don't be sloppy and come down and bring this up like this, because some people are doing that, and that's not accurate. We want to be careful with that and bring our line down and then run down towards the asymptote with your arrow. When I plug in a value over here on the left side of my asymptote, I want to go ahead and maybe try -5, -6, -7. If I try too close to the asymptote, I might get a number down here, and that's not really telling me much about staying underneath or going above the asymptote. If I get a little bit of ways away from the asymptote, then I will know, because if I'm going to be positive or negative over here, then I know what I'm going to be doing as I before I get over there, because I have to either cross over the asymptote or stay under the asymptote. So let's plug in -6. If I put in -6, that's -6 minus 2, and the opposite of -6 minus 2. So that's -8 on the top. Here I get +6 minus 2, which is 4. That equals -2. So -6, I go over to -6, and I go down to 2. And I come up with an ordered pair between the -6 that I plugged in and the answer of 2 for my x and y. Okay, so now I can see that I'm going to be coming up and rounding over towards that point. So I'm going to come up here and I'm going to curve over and then follow the asymptote. So there is my graph. I'm done with number 5. So let's go over to number 6. Okay, I need to factor. So I have a common x here. So I'm going to, and a 2. So I'm going to have 2x. When I factor that out, I'm left with x plus 3. For the denominator, I will get x minus 3 times x plus 1. So for the x-intercept, I set the numerator factors equal to 0. I get 2x equals 0, which is x equals 0. And x plus 3 equals 0 will give me x equals negative 3. So x equals 0 and x equals negative 3. I'll go ahead and plot those on the graph. For the y-intercept, I plug in the value of 0. And again, I like to plug into the original function. So I will end up with 0 plus 0 because both terms have x. And anytime you plug in 0 to an x term, it will give you a 0. The denominator will be 0 minus 0 minus 3. So I get 0 over negative 3, which is 0. Okay, and I actually have that already on the graph because of my x-intercept being 0. For my vertical asymptote, I will have the denominator values factors set equal to 0. So x minus 3 equals 0. I get x equals 3. And also x plus 1 equals 0. I get x equals negative 1. And finally, for my horizontal asymptote, my n value is equal to my m. So I look at the coefficients, 2 over 1. So y equals 2 over 1, which is just 2. And now I go over to graph my asymptotes. My vertical asymptote was 3 and negative 1. And my horizontal asymptote was at 2. Okay? And now for the testing, I need to test values left and right of both vertical asymptotes. So that's negative 1. So negative 1.1 and negative 0.9. And for my 3, x equal 3 asymptote, I need 2.9 and 3.1. So let's go ahead and start with negative 1.1. When I plug in negative 1.1, I'm looking at the factored form over here. Again, you can just plug in and use your calculator, but I like to do each factor. So 2 times negative 1.1 is a negative 2.2, which is a negative number. I'm just plugging into that first factor. When I plug in negative 1.1 and add 3, I will end up with a positive value. When I plug in negative 1.1 and subtract 3, that would be a negative value. When I plug in negative 1.1 here for x plus 1, negative 1.1 plus 1 is a negative value. So I end up with 3 negatives, which is a negative answer. When I test negative 0.9, 2 times negative 0.9 is going to be a negative number. Negative 0.9 plus 3 is a positive value. Negative 0.9 minus 3 is a negative number. And negative 0.9 plus 1 is going to be a positive because I'm adding a larger value. Now I only have 2 negatives, which will have a positive outcome. So when I look at this, negative 1.1 is to the left of this asymptote. I will be going down. negative 0.9, which is to the right of this asymptote, I will be going up. Okay, now let's test the other line. 2.9. When I plug in 2.9, 2 times 2.9, I get a positive number. 2.9 plus 3 is a positive number. 2.9 minus 3 is a negative number. 2.9 plus 1 is a positive. One negative number is going to have a negative value for a result. When I plug in 3.1, that's going to be 2 times 3.1, which is a positive number. 3.1 plus 3 is positive. 3.1 minus 3 is positive. And 3.1 plus 1 is positive. All positives, you end up with a positive. So with 2.9, which is to the left here, I'm down, pointing to negative infinity. And with 3.1, I am pointing up to positive infinity. So I remember someone asked me, how do you know how many little graphs are you doing? Well, if you look at your vertical asymptotes and the sections that it creates, I have 3 sections, one here on the left, one in the middle, and one on the right. Well, that means I will have 3 little graphs. They will either be on the top or the bottom, possibly top or bottom in the middle, or just going through, and over here on the right, top or bottom. You will not have both on the sides. You will never have both, unless it's just one that goes down through and then curves out. Now for my left side, I have a point, so I'm good. I'm going to bring the line, my graph goes from the arrow, goes up through the point, and then curves and follows the y-asymptote. In the middle, I'm going to be going from the arrow up here down to the arrow down here. I'm not going to draw a straight line. I have to go through any points that are graphed here, and then it'll curve over like kind of like an S curve and then down. So I will come down, go through my point, curve over, and then follow to the arrow. Okay? Now, over to the right, I'm going to plug in a value, any one of these values, but like I said, I want to get a little bit far away from my asymptote. Now, I'm actually going to test 8. And if I plug in 8, I will get 2 times 8 squared plus 6 times 8 over 8 squared minus 2 times 8 minus 3. Now I caution you, anytime you plug in a number, put it in parentheses, no matter what. Because what's happening is that people are plugging in a negative number to square it, and it tells them that the answer is a negative number. And anytime you square anything, it will end up as a positive. So you need to put your numbers in parentheses. When I do this whole thing on my calculator, I need to put parentheses, extra set of parentheses around everything. I could calculate the top, get a number, calculate the bottom, get a number, and then divide those two numbers. Whatever you need to do to make sure you are taking the full value of the top, dividing it by the full value of the bottom. When I do this, I get 3.9 something. So I go to 8, I go up to 3.9. I'm going to plot my point right there at 3.9, and I can see that I'm going to stay above the horizontal asymptote, and I can go over, since I have my work over there, I'm just going to end right at that point and draw my arrow so I don't go over my work for you. Okay? And there's 5 and 6.